Okay, before we get into the different laws that we need to understand, there's just a couple of standard conditions that you need to be aware of. And these are the two types of standard conditions that you need to know. One is called standard temperature and pressure, and oftentimes it's just abbreviated STP. And the other one is standard ambient temperature and pressure, abbreviated SATP. All these conditions are just standard conditions. And so I don't know kind of how the conversation went or why it was decided this way, but I'm sure the reason why is just that scientists around the world wanted a set of standard conditions that they could all work in, where they could just say in their reports and things like that, hey, when I was dealing with this gas, it was at STP, rather than always having to report the numbers. And so you're going to see this in problems that you're doing and questions that have been assigned, in that you'll see in the question, it'll say, hey, this gas was at STP, or this gas was at SATP. And so you just need to remember that those are standard conditions, and those standard conditions are found in your data booklet on page 3. These numbers here, this one is 273 Kelvin, this is 0 degrees Celsius. And this is just the air pressure at sea level. And I'm sure at the time they probably thought that seemed pretty reasonable and good conditions to have. But then they may have, I guess, I'm assuming that's why this second one kind of came to be, was they were like, hey, working in a lab at 0 degrees Celsius is pretty uncomfortable. And dealing with numbers that are big, long numbers with decimals like that are kind of hard to work with. So they said, let's make an adjustment. Let's make our now conditions room temperature. That seems a little bit more reasonable. And instead of 101.325 kilopascals, even though that's sea level, they just said, why don't we just make it a nice good round number of 100? That's a lot easier to use in calculations. So I don't know if that's the reason why. It kind of seems like maybe that's how things sort of morphed over the history of it, but just kind of my opinion. Obviously this is easier to work with, these ones here, but you will see both. You'll see STP and SATP. Last thing I want to point out is this molar volume number here. All this is just saying is that when a gas is at this temperature and this pressure, it is going to have a volume of 22.4 liters for every mole of that gas. And then for this condition right here, SATP, at this temperature and pressure, that gas is going to have a volume of 24.8 liters for every mole of gas that you have. So it's just molar volume is very similar to molar mass, but instead of grams per mole, we're dealing with liters per mole. So molar mass, molar volume, grams per mole, liters per mole. That's sort of the correlation with the wording and the units there. Okay, and that's it. Thanks, guys. See you in the next video.